Record. Okay. So I've got two binomials inside of parentheses. There's this thing we do that starts with the letter F. Who can tell me what it is? Good, Tyrone. We're going to FOIL. Anytime you have binomials in parentheses, we're going to FOIL. So we FOIL. F stands for first. What are the first two terms?
2x and 5x.
2x times 5x. What is 2x times 5x? (10x squared). Very good. Because remember, when you multiply two variables, they multiply by itself, you square them. So 10x squared. Outside, what O stands for outside. What are my outside terms? So it's not -3 and 6. Think of it. Which ones are on the outside? 2x and 6. Yeah, that's right. So 2x times 6, what does that give me? So it's going to be 12, but it's just x because it's 2x and 6. The 6 doesn't have an x with it, so I only have one x. So it's just 12x. Cool. Then we get I. I is inside. Which ones are my inside terms? -3 and 5x. Good. What's -3 times 5x? Good, Jalen. -15x. And then finally, L stands for last. So that's everything left. So -3 and +6, which would be -18. Good job. Cool. And then after you FOIL, you check to see if there's any like terms. So do I have any like terms? Where are they? 12 and 15. Good. So 12 minus 15, I think Jalen put it already, is -3. So finally I have 10x squared minus 3x minus 18. And again, you would put that in your slot over here. Questions on this one? Tyrone, you have a question? No, you can't combine, right. You cannot combine the 10x squared and the 3x. You can't do this because one of them they have to match, both the variable and the exponent has to match. It has to be the same. Good question. Okay, cool. Let's do another one. Okay, so this is a word problem, kind of. So let's take a look. So the area of a trapezoid is found using the formula A equals 1/2 h, parentheses b1 plus b2, where A is the area, h is the height, and b1 and b2 are the lengths of the base. So notice we have a little bit of geometry in an algebra problem. Interesting. What is the area of the trapezoid? Okay, so we have the area formula. They gave that to us. And we know a few things about this trapezoid. We know the value, we know b1, we know h, and we know b2. So we're going to go ahead and use the formula and all of those values to figure it out. So I have A equals 1/2. H is 4. B1 is x minus 3. And B2 is x plus 7. Okay. All right, so we have a lot of different math things going on. And remember, whenever you have a lot of different mathematical operations in one problem, we always use PEMDAS. in order to check to like go in the right order. So P is parentheses. Can I do anything inside of those parentheses? Yeah, I can combine like terms. So what do I get inside of those big parentheses? In here. When you combine like terms, what do you get?
2x.
2x, good. Be very careful. This is not x squared because we're adding, we're combining like terms. We're not multiplying, okay? So all we're doing is collecting, grouping everything together. So I have 2x plus what? 2x plus what? I collected all of my x's. Now I have -3 and +7. Not 5. Do your math, Jalen. 4. There you go. 2x plus 4. Good. All right, so we did parentheses. Great. No exponents. Now, okay, I can multiply. And we can multiply from left to right. So let's just start by doing 1/2 times 4. What's 1/2 times 4? 2. Good. Easy, easy. Okay, and now we multiply 2 times 2x plus 4. What should I do here?
Are you asking for the answer, Miss?
Yeah. So I'm just
Oh,
good. I distribute and I get Janelli says 4x and then 8. So 4x, good, plus 8. B. All right, so don't get too scared if you guys see a shape in there. Usually they're going to tell you the formula and then you just plug everything in. You don't really need to do more than that. You just plug things in.
sometimes in the reference sheet too, like the one
Yeah.
they give us, it sometimes says it too.
Mhm. Yeah, you guys get a reference sheet and it'll be like the area of a circle, area of a trapezoid, area of a triangle, area of a square. It'll tell you all the area formulas, so you don't have to memorize them because it'll give it to you. If it doesn't tell you on the test, it's going to be on your reference sheet. Okay? Cool. All right. Whew. We're multiplying again, except now there's like a lot. Okay, so this one's a little bit longer. We're not just doing 2 binomials. We have a binomial times a trinomial times another binomial. So when you get something like this, what I suggest personally, I think the best way to do this is I'm going to just move things around because I know how to FOIL. So which 2 would I FOIL? Which of those would I FOIL? Mm-hmm.
-2x minus 3 and x minus 2.
Yeah, this one and that one, because both of those are binomials. And I know that foiling works with binomials. So I'm just going to kind of rearrange everything. And I'm going to put these 2 next to each other. That way I can start by foiling those, and then I can move on to the other one. So we're just going to start by foiling the first 2. -2x times x, what does that give me? Very close, Jalen. Remember that we're multiplying though. So it's -2 times 1, not plus 1. Yeah, so just stay at, yeah, it would be -2 x squared. Outside, -2 times -2 x.
Plus 4x.
Good. Plus 4x. Why am I adding?
Negative times the negative is equal to a positive.
Good. A negative times a negative is a positive. Inside, negative 3 times x. Negative 3 times x. Good, Jalen. Negative 3x.
Jalen stole my answer again.
And then negative 3 times negative 2. Is 6. Good. Okay. So I've got that whole thing times 2x squared minus x plus 1. Okay. Well, now let's combine like terms. What can I combine?
That'll be 1x.
2x squared and 2x squared.
Well, okay. We're not multiplying yet, Tyrone, but I'm just combining like terms. So yeah, this would be 1x. So now I have negative 2x squared plus 1x, or plus x, plus 6 times 2x squared minus x plus 1. Okay, now Tyrone, now we're going to do FOIL, but like a bigger FOIL. So instead of having 2 binomials, I have 2 trinomials. Okay? So I need to multiply everything times everything. So what does that mean? First, I'm going to multiply the 2x squared with everything that's on the other trinomial. So I start with 2x squared, negative 2x squared times 2x squared. What do I get?
Negative 4x squared.
Negative 4x. Be careful, we're multiplying
The fourth power. I don't
to
know.
the 4th power, yeah. Because what did I just do? I just did negative 2x squared times 2x squared. Remember that when you square something, it's because you're multiplying it by itself. So this is the same as negative 2 times x times 2 times x times x. Okay, so this is, how many x's do you have? You have 4. So this would be negative 4x to the power of 4. Questions on how I got negative 4x to the power of 4? Okay, so I got that. Now I multiplied negative 2x squared times the next term. So now I bring it all the way to this one, to the negative x. So what's negative 2x squared times negative x? Yes, we're basically adding the exponents, yes.
Negative 3x squared.
This would be negative,
Oh wait, negative 3x cubed.
so it would be x cubed, you're correct about that, but again, remember we're multiplying.
Oh yeah, positive. Never mind.
So it'd be positive
2x.
plus 2x to the power of 3, exactly. Exactly. Questions on how I got 2x to the power of 3? Okay. Then I do it again. Now I'm bringing this, distributing it all the way to the 1. Negative 2x squared times 1 is just
Negative 2x squared.
negative 2x squared. Okay, I'm done with all of those. Now I go on to my x. But do I have any questions so far? Make sure you understand how I got this. Do I still have any? This is it, guys. If you don't get it now, I'm not teaching it again. Ask your questions now.
Are we gonna have to do this for each term?
Mm-hmm.
Okay, so we'll just get like a really long equation.
Super,
and then we
super long.
just-
Mm-hmm.
Okay.
Okay. So now the x goes to everything. X times 2x squared.
2x cubed.
2x cubed, exactly. All we're doing, because remember, if an x is all alone, technically it has an exponent of 1. So again, we're just adding those exponents. We get 2x cubed. Then x times negative x. What do I get?
Negative x squared.
Good. And then finally, x times 1. X times 1 is just just 1x, yeah. So I'm just going to leave it as x. All right, we're almost there. Now we distribute the 6 to everything. So 6 times 2x squared.
12x squared
Okay.
minus 6x.
And let me move this all along because it's so long. Okay. All right, so 6 times 2x, we said 12x squared. Perfect. 6 times negative x.
Negative 6.
Negative 6x. And then finally, 6 times 1, just 6. Good. Okay. We've got this super, super, super long polynomial, but of course we can combine like terms. So I'm going to keep everything nice and organized. Remember that with polynomials, does anyone remember the order you have to write them in?
The leading exponent, I think, and then it's the variable. I know how to write it, I just don't know how to say it. Right?
Basically, the exponents have to go down as you go. So yeah, Janelli, so the negative 4x squared has to go in the front because it has the largest exponent, and then you just keep going down from there. So we start with negative 4x to the power of 4. And now the next one has to be to the power of 3. So let's combine like terms. What can I combine?
You can combine 2x cubed and 2x cubed. Well, the 2x.
Yeah, I have 2x cubed plus 2x cubed gives me
4x to the power of 6.
We're just collecting them. We're just collecting them. Good. So we're just combining like terms. Since I have 2 of them, 4 in total, I got 4x cubed. Then I do my exponent of 2. So keep it going, combining like terms. What do I have?
Negative 2x squared minus x squared plus 12x squared.
Okay, what's negative 2 minus 1 plus 12?
Negative 3x and then 12 negative 36x squared.
We're adding.
Oh. Like,
Combining like
let
terms.
me just be quiet.
All right, somebody else. What do I get? Negative 2 minus 1 plus 12. Good, 9. So plus 9x squared. Okay, now just my x's alone. I have x minus 6x. What's 1 minus 6? How many x's do I have? 1 minus 6. Good, is negative 5. And then finally, my little 6 all by itself. That's everything. So my final answer, there's nothing else I can combine. I got negative 4x to the power of 4 plus 4x cubed plus 9x minus squared minus 5x plus 6. Okay, that's a very big polynomial, and we had to do a lot of multiplying, a lot of distributing. So this is kind of like what we've done so far, this was level 1, level 1. This was level 2, foiling, level 2. And then this is like a level 3 challenge question, okay? So when you have to multiply several different polynomials, you gotta really keep things organized. Look at all those strategies I used. I used colors. I crossed things off as I went just to make sure that I'm keeping things super organized. Do I have any questions? That would be my final answer because there's no more like terms that I can combine.
Ms. Lopez, I'm gonna take so long on these questions because I always make mistakes when I think I got it. So I'm gonna keep going back to make sure, and I'm gonna do the question like 3 times to make sure I got the right answer.
Good, because you have a lot of time. You might as well. Okay. So that was, by the way, that was all APR 1.1. Now we're starting a different standard. This is CED 1.1. So when you're doing your homework, just those are the ones you can work on tonight. All right, here we go. A fence is being built around a rectangular garden. The length of the garden is 35 feet, and the total fencing used to enclose the garden measures 160 feet. Which equation can be used to find the width of the garden in feet? What does Ms. Lopez always do when there's a word problem involving shapes? Good, Tyrone. I'm going to draw a rectangle. Because guess what, guys? The more you visualize it, the easier it's going to be. So I'm just going to make a little rectangle. Doesn't have to be perfect. But now let's fill in what we know. We know that the length is 35. We know that the total fencing measures 160. But what do we not know?
The length.
We know the length, but we don't know the
width, sorry.
The width, yeah. So the length is 35. The width, we don't know. That's W. And 160, what is that? Is that my area? Is that my perimeter? Is that the volume? What is that? Okay, so area versus perimeter. Area is whatever's on the inside, whereas perimeter goes all the way around. So if I'm talking about the amount of fencing, where does the fence go? Yeah, fence goes around. So the fencing goes all the way around. This would all be fence, 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 fence. So whenever it asks you about a fence, that's always going to be perimeter. And if I'm looking for the perimeter, what am I adding up? All the sides, exactly. I'm add up the sides. So what are my sides?
We have 235.
235s.
So that would be 70.
And what else?
And then we have 2W.
2 times W. Exactly. Because you got to go all the way around. So this is also W, and this is also 35. So in total, like Perla said, 2 times 35 is 70, and then 2W. And all of that is equal to 160. So which answer choice is it going to be? D? Good. D. Questions on this one? Yeah, C would have messed you up if you forgot to add 25 2 times. Okay, cool. Next up, here's another CED 1.1. A parking garage charges a base rate of $3.50 for up to 2 hours and an hourly rate for each additional hour. The sign below gives the prices for up to 5 hours of parking. Which linear equation can be used to find X, the additional hourly parking rate? Okay. So let's look at these equations and let's see where they're getting their numbers from. In A, where did they get their 9?
From 3 hours.
from the 3 hours, right? So they're basically saying if you start here, and remember, we're trying to find X, the additional hourly parking rate. So it's basically asking, okay, how much is it going to be for 1 hour from here on out? Like, how much is it adding? How much is it adding?
550.
550, good. That's the value, that's what X is, 550. But the question is asking, okay, which of these equations would give you the answer of 550? So there's a couple of ways to go about this. What's one strategy, what would you guys do? What's one thing I could do?
I would probably just look at it a lot, like I usually do when it's like this. Can you hear Tyrone's left his keyboard? Okay, anyways, I would just look at it and like just process it in my brain. Like I don't have strategies for this. I just look at it
And
and
like
then if I see a
process?
yeah, and if I see like an answer that looks right, I'll like try to do math for it, and then I'll see if it's right. But yeah, I don't have a strategy.
Okay, well, if I know that X is 550, like I know that's what it should be, one strategy I could think of is to solve each equation. Like this is equation A. We could solve for X and see if you get 550. So let's try that. So if I'm solving for X, okay, I would subtract 9. What's 20 minus 9? 20 minus 9 is 11.
Yeah, that's already wrong.
11 divided by 3, what does that give me?
3.666666667.
Right, so I already know that that one is wrong. And you could try the next one and the next one and the next one until you find the correct one. So would anyone like give me one that I should try? What do you guys think? What, C? Tyrone says let's try C. Okay, let's do C. 2x plus 3.5 equals 14.5. Okay, minus 3.5 on both sides. What's 14 minus 3.5? 14.5 minus 3.5. What's 14.5 minus 3.5?
11.5. I mean, yeah, 11.
Just 11.
Yeah, 11.
Good, now we divide it by 2. What do we get?
5.5.
5.5. Notice we got the right answer. That's what we wanted. That works out. That's our answer. Now, another thing you could realize is look what they did. They said, basically what they did is they're showing how when you start at the 350 and you add 2.5, or no, you start at 350 and you add X 2 times, you end up with 14.50. Because this is 2 hours, right? So that's what the equation is telling me, that if I start at the 350 and I add 2 hours, I end up paying 14.50, and you can use that equation to figure out the value of X. All right. So that's one strategy. This one's a lot of, this type of problem is really like looking at the answer choices and kind of figuring it out. There's a lot of different ways to do it. You didn't have to do it the way that I did it, but you basically want to do it the way that makes the most sense. Like figure out which of those answer choices fits the problem the best. Questions on this one? Thank you, Perla. It's a sweater. Alrighty, cool. Next one. Ooh, big problem. But again, we're just figuring out which equation makes the most sense. Tyrone, you want to read? Go for it.
Carmela just planted seeds for her vegetable garden. Anxious to view the progress of her plan, she checks her garden one afternoon. She checks her garden one afternoon, but sees that 4 weeds she has never seen before are growing in her vegetable garden. After a few weeks, she notices that the number of weeds appears to be tripling each week. If she doesn't do something, she calculates that there could soon be 972 weeds in her garden. If W represents the number of weeks, which equation could be used to determine what week Carmilla will expect to find 972 weeds in her garden?
Awesome, thank you. Okay, so I highlighted a couple of keywords, and the big word that I highlighted is tripling, because when something is tripling, what do we know? What type of function does that remind you of?
Exponential.
Exponential, very good. Tripling, that's going to be an exponential function. Which of these answer choices can I rule out based on that information if I know it's going to be exponential?
First one.
Good. A is out. What else? I'm still going to keep B in the running because remember that exponential functions are y equals ab to the power of x. So I know that the exponent has to be a variable. So which other one can I rule out?
D.
D. Good. So I'm looking for one that has a variable in the exponent. And then let's think about it. You guys remember we reviewed this recently. For exponential functions, what does the A represent and what does the B represent?
The growth. No. Yes.
Which one's the growth rate? Which one's the growth rate? The A or the B?
I think it's the A.
Other way around, it's the B. What does A represent? If B is the growth rate, what's A? Anyone can answer this one. Yeah, Perla, what you start with? The starting amount. So in this case, which one has the correct A and the correct B? C. Good. So this problem required you to remember a little bit about exponential functions. So that's something that we're going to definitely keep working on, but make sure that we're reviewing it when we do your homework, when you go rewatch those videos and review your notes.
Ms. Lopez, I'm gonna be completely honest. I was about to start solving each question.
That would take far too long. All right, next up. Another one, another word problem. Anyone want to read this one? Tyrone, go ahead.
A rectangular garden measures 13 meters by 17 meters and has a cement walkway around its perimeter. As shown, the width of the walkway remains constant on all four sides. The garden and walkway have a combined area of 396 squares. Part B, Part A, and Part B.
Part A, yeah.
Part A, enter an equation that can be used to determine the width, W, of the walkway in the first response box. Part B, determine the width in meters of the walkway. Enter your answer in the second response box.
Awesome. Okay. So they're asking for the area of this whole thing. Of that whole thing. Okay. Now, area, who can remind me, what is area? How do I figure it out?
Length times width.
Good. Length times width. Now, I know the length and the width of the inside portion of this inner rectangle. I know that the length is 17 and the width is 13. Okay? But when I add that extra portion of the cement on the outside, I no longer know how much it actually measures. I have a variable instead. So can anybody tell me, using what we know, along with, they have a little variable for the width of the cement is W? Can anyone tell me what the length and the width would be of this larger rectangle? So 13 is the inner portion, the red portion. Okay, that's the inner portion, but I need to know the whole outer portion.
I have an idea
What do you
of how
think, Carla?
to solve it.
Mm-hmm.
So it says that the garden and the walkway, which I'm guessing is like the whole big square and the little one combined together. So you would have to do 13 times 17 and then do 396 minus whatever you get. That might be wrong, but
Yes, you're correct. However, all I want is the width of the outer portion, not the area of the outer portion. So you're close. You're on the right track. Does anyone else have any ideas? Yes, so I need to multiply something, but I don't know what I need to multiply yet. You could do 13 times 17, but that's the area of just the inside. Remember, I need to know the area of the whole entire thing, including the outer portion.
Miss, it says that, wait, the walkway is the bigger square, right?
Mm-hmm.
So it says that the width of the walkway, oh wait, never mind. It remains constant.
What does it say? The width of the walkway
Remains constant.
remains
all four
constant
sides.
on all four sides. And they're telling me, look at the diagram. The diagram says that the width is W, right? Okay, so here, I'm gonna give you guys a little hint. I know that I need to know this whole measurement, right? For that and for this side. I know that from here to here, this is 17, right? I know that because I can see it up there. Because if that's 17, then this is 17, and that's 13. So I know that that much is 17, and do I know how much this is? This little tiny portion on the end? I don't know the number, but what are they labeling it as? W. So this is W, and this is W. So altogether, using that variable, keep the variable there, altogether, how can I write that? W plus 17, you're close. If this was, let's play pretend for a second. If this was 2 and this was 2, what would the whole thing measure? 21. How did you do that, Perla?
I added it.
Just added it. She did 17 plus 2 plus 2. But if this is W and this is W, I'm still going to add. It's just that I have a variable. So what do I get?
17 plus 2W.
Yeah, 17 plus W plus W,
also said that in the chat.
which is 17 plus 2W. That is the length of this rectangle. What would be the length, or not the length, but the width, using that same concept? What would be the width?
13 plus 2W.
13 plus 2W. That's the width. Okay, so that's my length and that's my width. So let me go ahead and just move this up. Well, now I need to know the area. The area is length times width. So this would be 13 plus 2W times 17 plus 2W. And what does that all equal?
Oh, 396.
396. I have that over here, 396. So my final equation would be 396 equals 13 plus 2w times 17 plus 2w. And that's what you would enter into the first box. 396 equals 13 plus 2w times 17 plus 2w. Questions on that? I know that was pretty tricky. And Jalen, yes, the area of the red square, you're correct. This would be 13 times 17, which is 221. But then you would have to figure out, you would have to figure out W. All right, so that would be part B, is to figure out the value of W. I'm actually going to skip that for now because that ties into quadratics, which we're doing later. So we might come back to that on a different day. Oh, thank you, Perla. All right, guess what, guys? The rest of this class is pretty easy. We're just going to solve a few equations and then we're done. These are easy. This should be simple by now. Okay, go ahead and write these in your notebooks so that you can practice. 20x minus 5 times 6x plus 4 equals 4x minus 6. Let me move this over there. What do I do first? Good, Perla, distribute. All right, let's do this. Negative 5 times 6 is negative 30. Negative 5 times 4 is negative 20. Now what? Combine like terms. Good. 20 minus 30 gives me?
Negative 10.
Good. Negative 10x minus 20 equals 4x minus 6. Now what? Move the x where? Left or right? Yeah, let's go. Move it to the left. Minus 4x minus 4x. What's negative 10 minus 4? Good, Janelle's negative 14x. Be careful, Jalen, because we're adding two negatives together, basically. We're doing negative 10 plus negative 4, or we're subtracting, so it gets more negative. No, you're not a dum-dum. Okay, that's why we're reviewing. All right, now what?
Add 20.
Add 20. Negative 6 plus 20, what does that give me?
14.
Positive 14. Careful, Tyrone, it was negative 6 plus 20. Okay, and then finally we divide. And I get x equals what?
Negative 1.
Negative 1, very good. X equals negative 1. And in your answers, you would just, I believe you would just write the number 1. I don't think that you have to write x equals, or negative 1, sorry. I don't think that you would have to put x equals negative 1. I think it would be correct either way. You guys know how Khan Academy, sometimes it's like you do it as a decimal and they want it as a fraction or the other way around? Okay, on these tests, just make sure you read it very, very carefully. If it says enter your answer as a decimal, do it as a decimal. If it says enter your answer as a fraction, do it as a fraction. And then if it doesn't say either way, then it doesn't matter. Both ways will be fine. Okay. Cool. Another one. Now we have an inequality, but same idea. What's the one thing you always have to watch out for with inequalities? Who remembers?
The way it's facing?
The way that it's facing, what might make it switch sides, switch directions?
If you divide by a negative.
If you divide by a negative. So just be careful. If you divide by a negative, you'll have to switch your sign. So let's see if that happens. We distribute first, 3 times 2x. 6x, good, Tyrone. 3 times -1. -3. Okay, now what? Move the 4x. Careful, Tyrone, it's not really combining like terms because when you combine like terms, they have to be on the same side. But are there any like terms on the same side? No, so we're not combining like terms, we're moving the 4x by subtracting. 6 minus 4 is 2x, so 2x minus 3 is less than or equal to 7. Now I plus 3, good. 7 plus 3 is 10. 2x is less than or equal to 10. I divide by 2, and I get x is less than or equal to 5. So I did not need to switch my sign around. Questions on this one? Easy, easy, easy for sure. Okay, let's make it a little bit harder. Now I have a fraction, and remember, fractions are the worst. We don't like them. We want to get rid of them right away, as soon as you can. So if I want to get rid of this fraction, what should I multiply by on both sides? Good, Perla. Always multiply by the denominator. Since my denominator is 2, I multiply by 2 on both sides, because that eliminates it. That eliminates my denominator. So now I'm left with x plus 4. And now this 2, I need to distribute it. So what's 2 times 4x? 8x. 2 times -6. -12, good. Okay, finish it out. See what you get. Take about 30 seconds. Go, 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 finish it. When you have an answer, go ahead and say it out loud. It's not B.
A lot of a lot of decimals, but I don't know what it's fraction for.
Well, keep it as a fraction. What did you get when you were solving?
I think it's A.
A. A is correct. Good. Subtracting 8x from both sides gives me -7x plus 4 equals -12. Then you subtract 4 from both sides. So you get -7x equals -16. And then you divide by -7 on both sides. So we end up with x equals 16 over 7. Alrighty, y'all. That was pretty much it. We didn't miss too much. These are all very similar, so that's all right that we didn't get to it. Again, 10 problems for homework every single night. So tonight is your first night. Get started on it as soon as you get home. Do 10 problems. Work on the same ones we did in class if that's helpful. I'm going to be uploading this PowerPoint onto Teams as well as your recording, so you guys can watch the recording if you have any questions, and everything will be on Teams. So just when you get home today, I will go ahead and just post everything on Teams. All right. All right. Bye, guys. Have a great day.
Bye.
Bye.